Hello everyone, welcome back, and today we will be discussing the last problem from our binary tree section of our SD sheet. So let's have a look at the problem statement. Let me just check if I'm live. Yes, we are. So the problem is serialize and deserialize our binary tree. Okay, so this problem says that you are given a binary tree. Okay, serialization is to store a tree in an array. So as you can see, basically in this problem we are given two functions. One is serialize, other one is deserialize. We'll come at code later on, but for you to understand that we are given two functions that we have to complete. Serialization means you have to store the tree in an array so that it can be later restored, and deserialization is reading back from the array, reading the tree back from the array. So let me explain it to you. Let's take an example and then we will see what we have to do in this question. So let's have a look here. We have a tree like this: 10, 20, 30, 40, and what was given to us? 40 and 60. It can be anything. For example, let's take this tree. Okay, what do you mean when we say that we have to serialize this tree? Basically, I want to flatten this tree in such a way that I get a string. You can say that we have to return all the nodes in an array, and that should contain all the nodes in this manner. See, if I serialize it, so I'll get 10, then in the next level I have 20, then in the next level I have 30. Okay, you can serialize it in any way you want. I am doing it level order traversal. You have to make sure that whatever result you get into this array, right, you have to finally return it. You have to take this input and deserialize the tree from this given array. Just give me a second. Hello. Oh, घंटे बजा दो भैया. अरे रिंग कर दो. Okay, so what we have is, okay, we have to deserialize it from the resultant that we are preparing from this given array. Okay, so if I convert it into level order traversal, 10, 20, 30, next I have is 40. Okay, you have to also make sure one thing, that we have to retrieve our tree back from whatever resultant we are going to create. Okay, so we have null for 40, right is also null. So see, what I'm going to do here is that we have to make sure that we know in the level order traversal also what is the resultant that we are getting. So I create 10, then next what I create is 20, next on the next level what I have is 30, then I treat the next level and store the answer, that is 40. Okay, then 60. In the next level, actually ideally for 30, when I was going to its left and right, it is null, right? I have to keep a track of those null values as well. And how can I do that? See, I am doing it in this way, that for 10, if I go to its next node, I know that it will be the left of 10, and if I go to its next node, means the next to next, that will be the right of 10. I know for that for sure. So I have to do it in this way, that if I go to the next of this 20, I should know that I have 40, then that is the left child of 20. So similarly, you have to perform these operations in such a way that you know that the left of 40 is null, and you can retrieve the tree back from it. Okay, that's how you have to do it. So basically, let me now show you what we are doing. Since you all are aware of level order traversal, how do? We just simply take a queue, okay, insert our values. The only extra thing what we are doing here is that, as I told you, that we have to keep track of all the nodes, the null children as well, because I want to retrieve my tree back. So what are we going to do? So this is your array, this is your queue, and then this is your array. Okay, fine, understand this thing. So initially I insert 10 into my array and I insert 10 into my queue as well. You know that very well. Now while your queue is not empty, you go ahead and remove this first node. You remove the top of the queue and insert the left and right child. Okay, but before you do that, you check, is your node null? Right now your node is not null, so insert the value into your array list. Otherwise, what do? You insert the first of all you insert the data which you have done as of now, and then next thing you do is you go to the left child and insert it into your queue. Okay, then you go to the right child and you insert it. Fine. Now your loop will run, your queue is not empty, you remove the first the topmost, means the one at the front of the queue, you remove this, it is not a null, it is not a null value, you insert it into your array. But then you check it, okay, you removed it, then you check what, that the left child of what is the left child of 20, that is 40, so you insert 40, and what is the right child of 20, you insert 60. So these things keep on continuing. Now the next node that you are removing from the queue is going to be a 30. So what will be the left child of 30? Left child of 30 is null. So we are going to keep a track of these null nodes in such a way that that into my, right now obviously we are not going to insert anything here. If you have a null value from your queue, if you get a null value from your queue, you insert it here as well. In that place you can do anything, like this is an array list of integer, you can insert -1. That's what we are doing in our code. Okay, so what was the, where were we removed this 30, and did I add it? 10, 20, 30. Okay, so I go to the left child of 30 and I insert it, which is null right now. 1 second, if I am node dot data, I just remove 30 and then we are adding node left. Okay, so you add this null value into your queue, and what is the right child of 30, that is also null, you insert it into your queue. Next element that you are inserting is, did I not, it should be added here, right? Okay, then the next element is 40, you remove it. Okay, you removed it because it's not a null value, you insert it into your array list, and then you add the left and right child of 40 also, null and null. Okay, that will be null. Then you remove 60 and add its value null again, means its left and right child is null. Then you come here, whenever you find a null, you insert -1. So that's how you are doing. Now the next thing, when you deserialize, what do you have is, you have this already, you have a array of these nodes with you. Okay, then the next thing what you do is, first you check out what is the size of your array, you take the size of your array, fine. Then you create a new queue, you create a new queue, and we do repeat the same process, just that we have to create a tree from the array that we just got from serializing. Okay, I run a loop over this array, whatever I have. So I know that root node will be the value, that is the node value that is in the beginning of my array, that is at the 0th index of my array list, right? So what I'm going to check here is that if my a dot get I, if this a dot get I will, I start from one index, this is I equal to 1, I start from one index. If this value is not -1, then I know that it is going to the left child of the node, parent node, that I have just taken from a dot get I. Okay, a dot get I is just the parent, not basically, it is actually the q dot, wait, parent is going to be the q dot poll. You have a queue, correct, you have a queue. From there, you, as you remove, you know that this is going to be my parent. Okay, and simultaneously you will get the left and right child from this array. So you check, if a dot get I is not equal to -1, that means the left child is not going to be null. So you just construct it, you take a node left, that will be a new node, and it will be a dot get I. Okay, and then parent that you have just retrieved from q dot poll, you add this link by parent dot left to this left node, left, and let's say left node, whatever, in code you will see easily. Okay, then in queue you add this left, fine. So this 20 will go into your queue now, and simultaneously we will do for 20 now. So earlier in my queue I had 20, I removed it. Okay, so now what I have in my queue is 20. I repeat the same process. If I see, I'll see that the parent currently is my 20. First of all, I have already created this link, 10's left is 20. Similarly, I'll create the link for the others as and when I get it from the queue. But we'll do one thing, we'll take the code and I'll do a dry run from code itself. See, let's take this piece of code so that you can understand. So whatever array you got, fine, you got some array, and now you create a new queue. Okay, node root is in array list. Let's say initially we had 10. Okay, we had 10. So into your queue, now this is the queue that I'm creating. In your queue you got this, you added this 10. Now you will iterate over your array list. You'll start taking the parent node, which will be the queue.poll. Okay, so you start from first index, because I've already added this into my queue. You start from 20. Now you know that this parent is going to be the queue.poll. So I just created a link by through this condition that a.get I was not equal to -1. So I created a link from 10 to 20, and in my queue also I added this. Okay, in my queue also I added it. Okay, and this has been removed for sure. Now in my queue I have 20. Now from the next piece of condition, a.get plus I, that means I am checking for this root. If this root is not -1, then this is going to be the right child of 10. So I form this link by doing parent dot write. I have basically created this link, and this 30 will be inserted into my queue. Got it? And I keep on repeating this process. So the next node is going to be, I have already done for these two. Now it is going to be 60, 20 or 60. Let us see. Now it's 60. Let's say q dot add root. So basically now I will remove this 20, and the next node that I've added is 60. Why 60? Because you can see that we have already done plus I, and already there's a for loop in which we are incrementing I. And why I is incremented twice? Because we have created link for left and for right, and now the next node that I have is going to be 60. So your parent is going to be q.poll. Now I'm going to create left and right links for 20. Okay, so if this value was not -1, definitely, which it is not, you are going to form the left and right child for 20. So basically now the next, what in my array list, what I would have is the left of this. What was the left of 20 in your root? 40 and 60. Okay, so what, it's, I think there's some mistake here. We will see that array is not proper. That is why it's creating issue. Okay, so we will check in our array what is the next value. So the next value in our array, I don't know where it was, it should ideally be 40, right? So this 40's link will be created like this, and I will add it to my queue. Fine. So one by one I am going to do this, and the next node, let's say, will be 60. So let's check for the case where we have -1. When we commit this case, when now the next iteration, I remove this from the queue, I check in my ARR of I, I will have null value. Okay, -1, because I am storing for null values in my array. I am storing -1. So once I have -1, I know that the root is going to be null, right? So I do not have to attach anything here. Basically whenever my a.get is not -1, only then you are forming this left and right link. So this is the reason we have added into our array another value like -1. It can be anything which does not belong to the nodes value of the tree. So that's how we are keeping the track. So you can have a look at the code now. See, serializing is nothing but simple level order traversal. Okay, and deserializing is just getting an array from there. Only we are doing an extra thing, that we are handling the null values by adding -1 into an array list, and one by one we are removing those values. Okay, we are again creating a queue so that we can keep a track of left and right child from the array that we have created using serialize. Okay, so that is all about this question. So Dayashankar, the next topic that we will be discussing tomorrow onwards will be, let me tell you, it will be binary search tree. So you can follow this SD sheet that we have. Okay, in your SD sheet we are going serial wise only. So we just completed binary trees, and tomorrow we will be starting for check for BST question from binary search tree. Okay, and with this we are done with binary tree. So that was all for today, everyone. See you all in next lecture, that is tomorrow. Bye bye and take